Hi everybody, it's Mrs. Dunn again. We're talking about Venn diagrams and set operations in this screencast. What I want you to learn from this screencast is how to identify a disjoint, overlapping, or equal, or subsets from a Venn diagram. We're going to use a Venn diagram to find the union, intersection, or complement of sets. And we're going to use sets listed in roster notation to find the union, intersection, complement, difference, and Cartesian product. All right, so here are 4 pictures of different Venn diagrams. In Venn diagram letter A, we have 2 disjoint sets. So when you draw a Venn diagram, you usually use a rectangle to represent the universal set. And then you use circles to represent subsets of that universal set. These 2 subsets would be disjoint. An example of this might be like where we have the universal set being the set of students that take classes at Triton. And then A would be the set of students that are in math at 9:30 a.m. on a Monday. And set B would be those students that are in English at 9:30 on a Monday. Those students wouldn't overlap. You're either in math or you're in English. So we say those 2 sets are disjoint. Then we have where set A would be a subset of set B. An example of this might be where B is the set of math students and A is the set of students that have Mrs. Dunn for math. Where the sets are equal, that's self-explanatory, the sets would be the same. Like you could say students that are taking an online math course and with Mrs. Dunn and students that are in Mrs. Dunn's Math 102 Section 70 course, which would be the same students. The overlapping sets is where you have some intersection. So here, think about that universal set being the set of all students at Triton. And then you have students that are taking an English class, students that are taking any math class. There might be some overlap there. So these sets would be overlapping. Okay, let's look at an example of a Venn diagram that has some information in it. So first of all, this is the universal set, every single number that is in the rectangle. So those are all the numbers from 1 to 10, including 1 and 10. Set A are all those elements that are in A. So A is this circle here on the left, and the elements in there are 1, 3, 5, 7, and 9. In set B, we have the elements 6, 7, 8, 9, and 10. So first we want to talk about this idea of the complement of a set. The complement of A, denoted A complement, are all those elements that are not in A. So those elements would be, the elements that are not in A would be 6, let's start in numerical order, 2, 4, 6, 8, and 10. And just for the sake of argument, what about those sets that are elements that are not in B? And not in B are 1, 2, 3, 4, and 5. All the elements that are not in the B circle. Okay, next we're going to talk about the union. So, union is described as the union of A and B, denoted by A union B, is the set of all elements that are in set A or set B. So think about that. All the elements that are in A or in B are going to be all the elements that are in either of these 2 circles. So A union B is 1, 3, 5, 6, 7, 8, 9, and 10. The intersection of A and B, denoted by A intersection B, is the set of all elements that are in set A and set B. So that should be the numbers, the elements 7 and 9. Okay, you can do everything that we just did. Union, intersection, complement. If I just listed those sets in roster notation. So if I wanted A union B, I know I want all of these numbers and all of these numbers listed together. If I want A intersection B, I want only the overlap. So the overlap would be 7 and 9. A complement are all those elements that are not in A, but still in the universal set. And I'm just trying to point out that you can see that if it's listed in roster notation. You'll see both when you're doing your homework. Okay, a new concept is this idea of the difference of A and B. So the difference is those elements that belong to A but are not in B. So A minus B. So look at set A, look at set B, take all the elements that are in A but not in B. So A minus B would be just those elements 1, 3, and 5. We take out 7 and 9 because they're in B. B minus A would be different, wouldn't it? So B minus A, we're going to take out all those elements that are in A, keep the ones in B, which would be 6, 8, and 10. All right, the last concept is this idea of the Cartesian product, and that's pronounced A cross B. A cross B. And that's going to be a set of ordered pairs. That's the ordered pairs where you're taking, since it's A cross B, you're going to use the elements that are A first, and then the elements in B. So look at this example. A cross B would be the ordered pair 1, 6, 1, 7, 1, 8, then 3, 6, 3, 7, 3, 8. That's all there is to it. Good luck.